speaking.
Yeah, just ask.
No, the whole point is that you're
No, we'll pretend to be audience members. Hello, welcome to lecture 0 of week 2. So we're going to start labeling them like that.
Week 3.
Week 3, okay, I'm getting there. Week 3, lecture 0. So what we thought we'd do in today's lecture is actually slow things down again, like we did with Scratch. We went through it quite quickly and then we came back a week later and slowed things right down. And I think the reason for this is because it can be quite difficult to get to grips with what it is we're trying to do with whatever this is. This is called an IDE, but actually I want to explain it a little bit more in terms of, well, how is this actually running our code? And what I want today's lecture to look like is this. I'm going to go through a few things in the IDE. First of all, I'm going to explain what it is, and then go through some of the things that Oja went through last lecture. But I also want this to be a Q&A sort of lecture, where, with regards to if there's anything that I'm doing on the board that you feel like you want to question, like why are you doing that, or what is that, then I'd really like your engagement in it that way. Mataz is actually going to help me answer some of those questions as well. And Will and Ocean are going to ask some questions for you as well. Questions that maybe you're not quite confident enough to ask, or maybe you should be asking them but you don't know you need to ask them yet. But when it comes to doing the workshops where you're actually going to be using this, hopefully today we'll identify some misconceptions or some areas where you might make errors, and we can sort of isolate those now, discuss those now, so that when you do hit the workshops, you are familiar with what's going on. Okay, so this is not just a lecture, as it were. It's more of a Q&A and a demonstration. Okay, so first of all, I want to illustrate what this is. I mean, I'm in a web browser, and we know that this is called the CS50 IDE. Okay, we also know that we're going to a website called Cloud9 to actually get this IDE. But what is it? What is this IDE? Well, I thought I'd illustrate it by doing this. This is Windows 7, I believe. Yeah, Windows 7. It's an operating system that we have installed on the majority of computers here at the school. And this is a graphical user interface. What that means is when I switch my computer on, and it loads up like this, if I want to navigate through my computer, then I use graphics to do that. I actually use something called a WIMP interface. It's got windows, it's got icons, it's got menus, it's got pointers. And these are very intuitive interfaces. Yeah, because they're literally just point and click. So if I want to open a folder, I go down to this Windows Explorer at the bottom, and I open this folder, and I can go into my C drive, users. Now I can see how many people have logged onto this machine before, but I am Mark Wood, this is me, and inside there are all of my files. And I'm intuitively using this. I can give this to my daughter, and she can intuitively use this as well. But it's fundamentally just an operating system. Now, I could actually interact with this operating system in a different way. So, there's something called a command line interface. I remember the first time I ever used a computer. It was with my dad. I think it was called an Amiga, and we used to switch it on. And we didn't get any graphics like this, with pictures in the background and icons like this. We just get this. Full screen, black screen in the background, flashing little cursor with some squiggly writing up at the top there, not quite sure knowing what it means. And my dad would type a bunch of stuff in, and then eventually we'd play whatever game he'd load up that day. It used to be a snooker game, if I remember. But we can interact with our computers like this as well. So, if I just throw this over to the left, I know you can't see it too well, but basically, if you imagine my graphical user interface wasn't there, and my whole screen was this, then I can do pretty much anything that I've just done, which was go into a folder, navigate through it, find a file, open it. I can do that here as well. So I'm just going to illustrate that. If I go back to this folder using a graphical user interface, here's a file that I want to open. I've navigated to that file by just double-clicking some icons, and then I double-click the file, and it opens. I'm going to do exactly the same, but I'm going to do it this way. Now you'll see that automatically I'm in the C drive users marked wood, which was when I went to the Windows Explorer here. If you saw, what I did is I went to the C drive, I went to users, and then I scrolled down all the way to marked wood. And so if I put these side by side, like this, if I now go in here and type dir, what you can see on the left is a list, as it were, a list of folders and files. And what you see on the right is exactly the same list of folders and files, but this is text-based, this is using a command line interface, and this is graphical-based, using a graphical user interface. But again, I can do exactly the same things here.
Mr. Wood,
Yes.
how come in the CS50 IDE terminal I had to type in ls to see my directories, but I'm typing in dir here?
That's a good question. So we're using Windows 7. By the way, just so you know, none of these questions are pre-scripted at all, right? So I'm assuming that Ocean is genuinely asking that question, all right? So I'm using Windows 7, and you'll notice that I'm using this command line interface to do something like a dir instruction, a directory instruction. But you might have actually seen that you could do that in this IDE that we've been using, this Cloud9 IDE, but again, what is it? I'm getting to that point. And to do a similar thing in there, I write ls. And that's because what we're doing is we're actually, when we go to this web browser, we go to Cloud9, we are actually using a computer. We're just not using a computer that is using or running Windows 7. In Windows 7, if I want to use the command line, these are the instructions I have to give to the command line interface to see what's in that directory. I'm using a Linux machine, using an operating system called Ubuntu. Yeah. So when I actually go here, when you say, well, what is this? This is a computer. That I'm just opening that computer up. I'm opening its interface in a web browser. This is a computer. This is me interacting with a Linux operating system that's on a computer. And so when I type in the terminal down here, which is another word that I can use for what you've just seen as the command line interface there, I can write ls, and that'll do exactly the same as what I've just done with dir. And that's because, again, it's a different operating system, so it requires different instructions. So again, just to go back onto this, I said that I can do exactly the same thing, and I can. So I'm currently in mark.wood. I can see all of these files here. But when I wanted to open this file here, I just double-clicked on it. Well, I don't double-click on anything here, so I'll just try typing in CS50DC. Now, it's actually got an extension of .txt at the end there. If you can see the file, it's the one with the number 13 next to it. So if I put .txt and hit enter, that is exactly the same output as me double-clicking on a file in the graphical user interface. So what am I trying to illustrate? I'm trying to illustrate what, again, this is. And this is a computer. And we're just using it and seeing it through a web browser. Yeah.
Do you just need to type in the file name for it to run automatically, or do you need to type in the command? Because you opened it in Notepad, but you didn't type in any command to the set. You have to open it in Notepad or another text editor.
Yeah, that's a good question. So, you know, if I went in here, you know when, let's say that was I'm not going to waste my time navigating through files to find a Microsoft Word document because I don't know where one is on my files. But you know if that was a Microsoft Word document, it'd have the icon for a Microsoft Word document, yeah? And if I double-clicked on it, it would open it up in Microsoft Word. And there's two reasons for that. The first reason is the file extension at the end. .doc would be the file extension of a Microsoft Word document. And that is like a trigger to say, when you're double-clicked, open up in Microsoft Word. But why Microsoft Word? Well, I'm sure you've experimented with this before. If you go to properties of any file, you can actually change what these file extensions, so this is a .txt, you can change what they automatically open up with. So my computer, my operating system is set up in such a way that if I double click on that, or if I type the instruction there to actually open it, it'll just open it up with the piece of software that I've chosen to open it up with. And I can change that. So I can change it in here. And I can say that I want to open it up in Microsoft Word. And then I can apply that to all .txt files and it will open it up in Microsoft Word. Can I do the same in here? Can I open that text file up in here? Well, I can do it here. I can right click and I can go open with, and I can say open with Microsoft Word. And anything that I could do in the graphical user interface, I could do in the command line interface. I don't know the actual instruction. I assume that it's just Word followed by.
You probably have to find the location of the Word program, the .exe for Word, and then type the file name afterwards.
Yeah, so you need the full path.
Yeah, you'll need the path of Microsoft Word.
And again, if you want to do that, again, you just have to go to your C drive, go to your program files. Now, obviously, this kind of counteracts what you want to try and do here. That, oh, I want to see where that path is here so that I can type it in there. But some people like using this as opposed to this. When I was at university, in my second year, I had a third year helping me do my project. And I went round to his house, and he literally just used the terminal, which was the Macintosh's sort of command line interface, to navigate everything. He didn't even have a mouse. He just used his keyboard. Just a preference, because you can do some powerful stuff here that you can't necessarily do here, or you could, but they're a bit. This kind of hides some of the things that are quite dangerous, as it were, or you don't need. That's not for the average user. But the answer to your question is yes, I could do that, but it's actually set up so that it automatically opens in .txt. So, a long-winded way to explain what this is, but it's really important. We sat down and we talked about what should we be expressing to you, slowing things down. You're using a computer here, you're using it through a web browser. Any questions on that? Okay, so, what I'm going to do is I'm now going to start going through some of the C programming that we've looked at previously, and you might have actually looked at already in the workshops. But again, slow it down. Any questions, just put up your hand and feel free to ask. So right now, I'm going to create a new file. I'm going to save this file first. That's important, because if I want to actually compile it, then it needs to be saved somewhere. So I'm going to save it in this CS50DC folder. I'm going to call it something sensible, so for now this is just going to be hello.c. And you can see that's now appeared in here. I'm also going to open up a terminal, which we should now hopefully understand what that is. It's just a way of doing pretty much what I'm doing here to navigate files, but it also offers me something that this doesn't offer me. It offers me the chance to compile one of these files. And I don't know if you've tested this, but if I just write a simple program, and I say simple program, if there's anything in here that you want to know about, question, then please feel free. I'm going to do include. I'm going to put standard io.h. I'm going to do another include. I'm going to do cs50.h. No questions? I said anything you don't understand. Why wouldn't Harry?
What's .h? What does that mean?
What is the .h? Yeah. Well, do you know what that CS50.h is, or are you specifically saying what is .h?
Yeah, why the .h? Yeah, because I know that, well, like you said, it's standard IO. I think that's been explained before, but it's the why is there the .h extension on that?
So .h stands for header, and a header file usually contains a bunch of functions or other procedures that you're going to use inside your programs. So when you write this program, you don't have to include all the other functions that you're going to be using in it. So the .h file is somewhere else in the computer, and it's just being used in this program. So by including it, you're allowing it to be used, the functions that are in it to be used in your program. The reason it's .h is just its convention for header.
Wait, if the extension is .h for that, how does the computer know it's written in C?
Good question, it doesn't.
It doesn't. Okay.
It doesn't know that it's written in C. So when you compile a file, when you're doing clang, you have to specify that it's you have to specify the name of the file, but it's not going to check whether it's a .c file or anything. It doesn't matter what the extension is, essentially.
Could you just import certain methods from the header, or do you have to import the whole header when you include it?
In C, you would include the entire file.
So you can't do import X from Y like you would in Python?
No, but in other languages you could choose what you want to import.
I'll show you what that discussion means if you're kind of lost with that questioning. So, I did a bit of research last night and found this. This actually is CS50.h to an extent here. So basically, this is the header file that actually pulls in some of the code from here. So when you're using getInt or getString, they're actually functions or methods, as it were, that are actually written by Harvard, the CS50 course, the Harvard course. They actually wrote these to try and give you a little bit of help to start with. I say to my year 7s, you know, we can't go really deep straight away. All right, we can't start programming in assembly language straight away. We've got to learn a higher level language. And so we give you some training wheels. Yeah, I don't throw my daughter on her bike straight away without stabilizers. I get her used to the balance, and then when she gets used to that, I take the stabilizers off, and she understands how it works. Yeah, so with the idea of getString and getInt, well, getString, you'll soon realize down the line that is actually, so Harvard have written that. That's not how you get a string. And actually, if you wanted to have a look, again, I just typed in a little search here. I've found getString over there. These lines of code here. This is what's actually happening in order to allow you to get a string from the user and then use it. But you don't need to worry about that. We can abstract all of that. Yeah, we don't need to worry too much yet to start with about the detail. We just want to get a string from the user. So if we just know we can write getString, well then that's fine. And then we can start to understand that later, and we can take this apart, we can take the stabilizers off the bike, as it were, and have a look at how this is actually working. But that's what that does. It includes all of these functions which I can use in my program. So I haven't got to worry about writing all of this every time I want to get a string. Okay, so I'm now going to start writing this simple program, as it were. Well,
you know you're saying int main.
Yeah.
Isn't an int like a variable? So why are you calling it int main?
Well, I tell you what, I'll have a go at explaining this one, and if it doesn't make sense or if I go wrong, Mataza can butt in. Okay, so I don't know how much you know about functions yet. We'll certainly learn about them a lot more. But can you remember when we looked at Scratch and we said to start some code, any code, in Scratch, we have to have an event. And the event tended to be when green flag clicked. Yeah? So first of all, we explained this in the previous lecture. That int main void is like that green flag. So we're not worrying too much about int, but I need that so that when my program runs, it knows that that is the block of code that it's got to execute. So you could just say, yeah, well, why doesn't it just say main void? By the way, the word void means that I'm just not passing anything to that function. And if you know what functions are, you can realize that they can take arguments or they can not take arguments. And the fact that I put void in there just means currently, right now, I don't want to give this function anything before it executes. The int, on the other hand, is when this function actually executes, it does return something. In a sense, it will return a 0 or a 1. And the idea is that if it returns a 1, then there's potentially something wrong with your program. And if it returns a 0, then everything's all right. So your operating system, as it were, or your compiler, as it were, would see, well, if I run this function, am I getting a 0 output or am I getting a 1 output? If I'm getting a 1 as the output, as the return value, then there's something wrong with this program. It doesn't work. But if I get a 0, then everything's fine and I can execute it.
we will actually work with exit codes later on in the course. So we'll learn how to actually make the main function return a different value so that you know there's some kind of error. Yes?
Would you start every piece of code with int void?
Well, so you would start, when you write a program, the main bit of the program would be in main. And then if you wanted to call other functions, you wouldn't call them main. So other functions that wouldn't necessarily run at the beginning, you could call them something else. You could name them after what they do. But the main function is what's going to run when you run your program. So everything line by line is going to run inside there.
So just to elaborate on that, Matilda, you're saying that, what about if I create these other functions, are they in main void? Or do I create them outside of it?
So no, you don't create them inside in main, you create them outside, and then you basically call them, or you run them from within in main void, but you don't write them from within in main void.
Are you sure that's clear? Yeah, because later on like we say in the course, quite soon, we will start writing more functions. But as Bataz has just said, we will write those functions outside of the int main void, but we might want to access them from int main void. Yeah? Okay. So, int main void, I'm going to create a variable to start with. In fact, I'm just going to print something out that says print hello. Okay, so I'm going to run that code. Can anybody see anything? Is it going to work, do you think? Matt, what we're doing?
I want a semicolon at the end.
Good, yeah. I mean, how many times have we made this between us, whether it's in the workshops or whether it's previous? It's a common mistake. You'll probably still make, I'll probably make it whilst I'm doing this.
Should be printf, not print.
Ah, yes. That was not on purpose. Now what's nice about this is I should have actually spotted it, because this IDE, which is the environment that I'm writing this code, it's kind, it's generous. It uses these colours to help me spot what mistakes I might be making. Again, we know that we can swap to the night view, and these colours look a lot prettier. Yeah? And so these colours will actually help us along the way to see if we do have any errors in our code. Okay, so what I want to do now is, well, I'll just compile it to start with. So down here, I'm in workspace. So again, this is a classic example of what I showed you at the start. I'm currently in workspace, and if we have a look at the top right up there, there's a folder called workspace. So that's like me being in the command line mark.wood. Now, if I just have a look at what's in here by typing ls, notice that it's not dir, which is what you would do on Windows 7. This is Linux, this is Ubuntu, that's the instruction it needs. And I can see these folders. Here there's no files, these are all folders indicated by the slash here. These are all folders, and they're all the folders that I can see on what you class as the graphical user interface on the left hand side. So I need to go into them because I've saved this in CS50DC. So I'm going to change my directory, which is what CD is, and I'm going to go to CS50DC. I'm now in there, as you can see at the bottom. I can have a little look, a little peek, see what's in here. And because there's no slash after this, I can see that this is actually a file. Yeah, so I'm going to make this file. What's happened there? What have I done there? That's the name of the file. It says there. Oh, I've actually done two. What have I done?
You said mail.
I've just said mail. This is not the mistake that I tried to make. This is the one that I tried to make. Oh, what's happened there? What did Ocean say? Oh gosh, look at all of that. That's absolutely loads of errors there. What have I done? Shall we have a look at what I typed? I typed in everything right, didn't I? What did I do wrong? I made make hello. What have I done on it?
Hello.c.
Yeah, this is the file that I actually, it's called hello.c. That's the file that I want to compile. Just as the file extensions reported when I was in the directory on the command line down here, like I had to put .txt to open it. Then I need the file extension. I saw someone make this mistake in the workshop the other day. Oh, nothing to be done for hello.c. Hang on, what have I done? There's nothing to be done for hello.c. I'm still getting there. What's going on? there's kind of some key indicators in this IDE that something's not right. It's kind of a nice colour that's standing out for us. I haven't saved it. At the top up there in the tab, there's a red circle on it. Yeah, this means I haven't saved it. Now I've saved it. Again, this IDE is very kind. It gives us some nice colour indicators to say whether things have gone right or gone wrong. Let's try it again. Again, I don't have to keep typing that in. I know that's the right thing that I want to do. I could just press my up arrow. Oh, what have I done?
Try and make hello.
That's right, I was wrong before. That's not a mistake that I was planning on, but you're right. It's not .c, it's actually make hello. I watched a classic video last night before we did this. If you go and watch Lecture 2 of David Malin, I hope he gets a chance to watch this. If you go and watch Lecture 2, which is actually Lecture 1, it's actually Lecture 1, so Lecture 0 and Lecture 1. Go and watch that, and there's a bit where we've talked about making mistakes on purpose. And he's really good at it. He makes them on purpose, but he doesn't make it look like. And there's a classic video on his Lecture 2, which is actually called Lecture 1, where he does exactly what I've done. And he just keeps doing it, and he keeps making mistakes again and again and again. Gets a little bit flustered. But we're all going to make mistakes. I've made one there, hands up. Don't worry about it, that's when your rubber duck comes in, if you want a rubber duck. Right, I've made it. Now, how do I run it? Mohammed?
/hello.
/, and then I just type hello.
Hello. Yeah.
Yeah? Will,
What does the // do?
what does the // do? Whilst I sort this out.
Dot means the current directory, and slash is so // means in the current directory, and then hello is the name of the program. So you could, I mean, the reason you can't just type hello is because that could be a program called hello somewhere else in the computer. Like when we type clang or make, they're not in the current directory, they're somewhere else. // explicitly tells the terminal that I want to run the program called hello that's in the current directory.
Notice I made a mistake again. I didn't put this /n in there, which is me wanting to force a new line. So I've added that now. Now what I want to do is I actually want to get an integer, a string from the user. So I'm going to do this. Be handy if you can spot anything. Whoops. Now what do I need to change in here in order for this to work? There's a couple of things that I need to do, and I'm thinking, why do I need to do them, first of all? What do I need to do? What do I need to change? I want that to say hello and then whatever the user types in. Well, there's quite a few things going wrong here. What's that going to be?
Something on storing the string that you get anywhere.
Right, so that's the first one. Okay, so shall I store it somewhere? What shall I store it in? Name?
No, in a variable, say, user string.
Right, well, I'm just going to call it name. Is that enough?
No, you need to define name first, so you need to do str name equals,
Why?
because otherwise the compiler won't know what kind of data a name is. It's
Good.
going to be binary.
Yeah.
You need to tell it it's a string for it to be displayed as a string when you use it later on.
That's right. There's a lot of different data types that we're going to learn about throughout this course. And we need to tell C, as it were, what data type it is I'm going to store inside that variable name. Now, in some programming languages, if you've used something like Python, you don't need to do that. You actually don't need to tell it what data type you're going to put inside the variable. Is it str or string?
String.
But in C, I do. Is this right though? Is this right now? What else am I missing, and what else might I be doing wrong? There's some sort of fundamental problem I've got here.
This get string supposed to be capitalized because most.
Is it supposed to be capitalized? This here? Yep, that is supposed to be capitalized. It is that. Anything else? Will this say hello and then my name? No, what am I missing out then? What am I trying to get at here? Keep going then, Mohammed.
Sure. You need to rearrange, or you just need to add a print function below the get string line, and I would say hello, then I think it was /s,
Okay.
and then
All right. So the first one is I've got these in the wrong order. Yeah, I actually want to get something from the user, and then I actually want to put it in a variable, and then I want a string to go and say hello, and then go to the memory, get the variable, and put it in it. There's going to be some sort of logic problem here in the sense that, well, I'm going to print hello, and you know that what I want to do in here in a minute is put the string in there, but I don't ask you for the string until the following line. So I should definitely be putting this above this. Right, anything else? So what were we saying, what needs to go in here? Yeah.
It's backslash s, and then you need to
Backslash s,
percent s,
%s.
and then after the second quotation mark, so after this, just inside the edges there, you need to write in comma name.
Okay, so let's have a look what this is doing. So this is acting as a placeholder for where I'm going to put a string in a minute. Now, I can put multiple strings inside these quotation marks. I can put multiple placeholders inside there. But what will happen is, I need, after this comma here, I need what variable value I want to put back into those placeholders in the right order. So if I wanted to do something like this, if I wanted to say, well actually this is going to be your first name, and then I want to ask you for your last name. So what I could do is put, I could put this. I could put this in there. I could put this in there, but what's going to be the problem here?
You've got last name first.
Yeah. Yeah, so basically it's going to put L name into this placeholder and it's going to put F name into this placeholder. Let's just check that that's right. So I need to save it because that's indicated from this red circle up here. I'm going to make it. I'm going to run it. Right, obviously I should have put some user-friendly prompts in there, but I haven't, so I'm just going to type in my name. I'm going to type in my surname. And again, that's the problem that I've got. So we can pass multiple variables into those placeholders as well. So if I just, how can I rectify this? This wasn't very user-friendly, so what can I do? Any ideas? What can I do, Harry?
You could do print f, and then make it print name dash maybe.
Like that?
Yeah, so, yeah.
Yeah. Should I ask the first name?
Yeah, first name, and then you want to make sure you do a space after the colon.
Colon and a space. Yeah.
And then yeah,
And do that there as well.
yeah, but you want a new line after the first. Yeah, somewhere in there you need a new line.
Yeah. Shall we see what happens if I don't put a new line in? Yeah. Let me save this and see what happens if I don't put a new line in. Okay. Everything. Oh, hang on. Oh, classic. Try it again. It's running very, very slow today. First name, Mark. Last name, Wood. Hello, Mark Wood. Wood Mark. So if I rectify that, notice that I didn't. Why did I not need a backslash n? Why did I not need a backslash n here to force a new line? Yeah.
Because each printf statement starts on a new line.
Each printf statement will force a new line. Yeah, each printf statement will force a new line. So I didn't need one. If I wanted to just simply put something after here, like a variable, but I wanted it on another line, I would have to put a backslash n, but I didn't need to do that. So I'm just going to swap these back around.
Actually, it's because you pressed enter after you typed in your name.
Is it really?
Yeah.
Printf doesn't force a new
Printf
line.
doesn't do any new lines.
In Python it does, but not in C.
So if I run this again and don't press enter, or is it because, well, I'm
Well,
forced
you're gonna have to press enter, yeah.
Exactly.
If you remove the get string, which means you wouldn't get a chance to press enter, you wouldn't have a new line.
So if I didn't press enter now, but because
No, you have to press
because I've got string, I'm gonna press enter
Yeah.
because I want to send that value to the variable,
Yeah.
and it will actually press enter. There you go. We're all learning. Right. Are there any questions about that program? No. Right. so now I want to write a little program. How are we doing for time?
We have
5 minutes. 5 minutes.
5 minutes. Okay, so I'm going to write a very quick little program. In fact, no, I'm not. I'm going to stop there. What I was going to do is write a quick little program to do Celsius to Fahrenheit. But I'm going to stop this video. That was week 3